Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So here we have the energy and the stopping potential, and we have to find the watt function from the given data. Now from equation 27.5, we know that equation 27.5b, we know that uh, the energy or H times F is equal to the maximum kinetic energy plus the watt function. And this is basically the photon energy. So we can write this equation as K max is equal to the total energy of the photons minus the work function. Let's call this equation 1. Now you will also find in section 27.3 that the maximum kinetic energy is equal to the potential difference in electron volt or the stopping potential. So E times V naught, where V naught is 3.8 volt, which is already given. So the maximum kinetic energy here. Okay, so let's use this later. Now we will plug this value of kinetic energy into this equation and we will get, let's call this equation 2. So we'll use equation 2 in equation 1 and we get EV naught is equal to E minus the work function W naught. So work function will be then E minus EV naught, and the energy is given to be 6 electron volt and the stopping potential is 3.8, so it will be 3.8 electron volt, and then we get the work function to be equal to 2.2 electron volt. Now in the next part of the question, we are said that the photon's wavelength is doubled. So lambda tends to 2 lambda and we have to find the energy. We know that E is equal to hc over lambda by now. Since hc is a constant, E is inversely proportional to 1 over lambda. So if lambda is doubled, it means that electron will be halved. So in this case, if our lambda is doubled, our energy will be equal to then 6 over 2, or so 6 is the photon energy now. So, so 6 is the photon energy when lambda was not doubled. So after lambda is doubled, the photon energy will be half of this energy. So it will be then equal to 3 electron volt. Now using this value of energy in this equation, we can find the kinetic energy max. Let's call this, let's put it double dash here to separate this from this. So kinetic energy max in this case will be then E minus the work function. So energy is 3 electron volt here, and we found the work function to be 2.2. So this will give 0.8 electron volt. Now if lambda is tripled, energy will be the initial energy over 3. This means the energy will be 6 electron volt over 3. This means the energy will be 2 electron volt. And so the maximum kinetic energy in this case, let's call it triple dash, will be E minus the work function, which will be equal to 2.0 electron volt minus 2.2 electron volt. Now we see that this kinetic energy is coming out to be negative, which is not possible since energy is less than the work function. This means that in this particular case, when lambda is tripled, no current will flow. So I'll just write it down here. So in this case, no current flows.